anybody of you please share your email so I can share the data?
Can
Yes.
you please?
Yeah, please share email so I can send the data. Okay, thank you. So I have shared the data. Can you please let me know if you got the data?
Yes, I downloaded.
So you downloaded it. So
Yes.
we are starting in next 5 minutes, 10 minutes, or when?
Yes,
Do
I
we have
think.
the subjects?
I guess we can start in 3 minutes.
Okay, sure.
Hello, everyone. Uh, can you hear me?
Yes,
Yes,
I
yes.
can hear.
Welcome back to MDS Talks. Today it's the sixth episode, again with our wonderful guest, Zaid Ahmad Awan, a senior data scientist at Real Cyber Inc. I hope you are all ready, and welcome back, Zaid.
Thank you.
So I think we can start.
Sure. So let me just set up
Okay.
some things. So I'm sharing my screen. Just a second, guys. Okay, I'm sharing my screen. So, guys, please share the data with everyone. So, do you have Jupyter Notebook or Google Colab, anything, or VS Code? So, this in this session, we'll be doing live coding and will be performing some data munging, some kind of data munging or data modeling and data pre-processing using Python. And then we'll clean the data, we'll pre-process the data, we'll clean the data. Once we are done with the cleaning and pre-processing part, so we'll be uploading the same data in Power BI to create some basic level of charts like some cards, some filters, some drop downs, some bar chart, line chart, etc. So data modeling is different in ETL and in different data modeling is different in data science processes. So when we talk about data engineering side, so data modeling is all about converting your normalized data into a uh, denormalized denormalization fashion. Like you have highly normalized data, which is in third normalization form in your operational databases, your OLTPs, and from those operational databases, you pull the data and you model the data and you transform the data into denormalized fashion, and then you create some dimensions and factables, and then you use those dimensions and factables to create some kind of dashboards. But in data science, data modeling and data pre-processing is little bit different. In data science, you have to clean the data. It could be a single
Please,
flat
Zaid.
file. Yeah,
Sorry for interrupting. I just can see your screen
yeah, I'm sharing my
so
screen.
that I can give you the accent. Okay.
I'm sharing my screen. So
Okay.
let me know when my screen is visible.
Yes, now I can see it. Yeah. So you can go.
So can you see my VS Code window?
Yes, now we can see it.
Okay. So we have two type of data modeling. Let me open Paint. So we have two different processes. One is data engineering and second is data science. So in data engineering, when I say data engineering, and the second is data science. Okay. So in data engineering, data modeling is converting. You have two type of databases. One is your OLTP, OLTP. So OLTP databases are your operational databases where you have data in third normal form, that is 3NF. 3NF, third normal form. So from OLTP, you pull the data and you create another database. You create a data warehouse, and that data warehouse we usually call OLAP. OLAP. So from this 3NF format, you have to create some kind of dimensions and fact tables. So this process is called data denormalization. So we denormalize the data, we create different dimensions and different fact tables, and we store these dimensions and fact tables in our OLAP system, and then we use these data warehouses or data mart to create you know dashboards by using maybe Power BI or Tableau or ClickSense or MicroStrategy, whatever. So, and the second process is related to data science. So, in data science, we pre-process the data. It could be a single flat file. It could be it could be a single flat file, or it could be a multiple file. Can you see my screen of this paint, or just one screen?
We
Let me show.
are
Now no,
Let
but it works good.
entire screen. Just a
Now no,
second.
we don't see anything.
So can you see my screen? No.
Yes, now
yes,
is
now
good.
we can see. Yeah.
Yes.
Okay, sorry, my bad. So we have two different streams. One is data engineering and second is data science. In data engineering, we normally follow a process which is called data denormalization. So we have two type of databases. One is OLTP and second is OLAP. So OLTPs are your transactional database. So in OLTP, we have data in 3NF, which is third normal form. So we pull the data from OLTP or transactional databases, and we create dimensions and fact tables. So what are dimensions? What are fact tables? I'll be explaining in a moment. And then we store those dimensions and fact tables in OLAP. OLAP is nothing but your data warehouse or your data mart. So after storing the dimensions and fact tables in our OLAP, we create data models. So there are three famous data models. Let me list down those three different data models. So one is star schema, SS, which is called star schema, and second is Galaxy schema, GS, and the third is snowflake schema, again SS, SNS, snowflake schema. So star schema is very simple type of schema. Galaxy schema is little bit complex, and snowflake schema is also little bit complex. In star schema, what we do is we create one to many or many to many kind of relationships between dimensions and fact tables. So let's say I have four dimensions and one fact table. So I'll create a one to many relationship between all the dimensions and fact tables. So like dimension 1, dimension 2, and then dimension 3, okay, and then dimension 4, dimension 4. So we'll create a schema like this, and it will be one to many relationship. You'll have distinct values, like dimension when one could be state, so the information related to state, like state 1, state 2, state 3. Dimension 2 could be your identity card number. Dimension 3 could be your store name. Dimension 4 could be your product name, right? And fact table could be your sales table. So this is how we create schemas. So this is what we call star schema. And in similar fashion, we can also create Galaxy schema and Snowflake schema. But these schemas are little bit different. So in Galaxy schema, you can have more than one factables. In Snowflake schema, you can have more than one factables. And in Galaxy or Snowflake schema, you can have sub dimensions as well. So this is a very layman or simple kind of introduction in very layman terms. So we'll start with the data set. This data set is related to Cristiano Ronaldo, and we'll try to analyze. First, we'll try to process this data, and then we'll create a file. This is a single flat file, and then we'll be using this clean data, and we'll upload this data to our Power BI desktop, and then we'll create some kind of charts. So if you guys don't have Power BI desktop, you can download this. So this is Power BI desktop. You can simply go to Google, and you can download this. So Power BI desktop. So download from this link. I'm sharing this link. So I've shared the link. You guys can download it from this button. Download free. All right. So let me copy the details. So let me know when you are done with this download thing. So you can download, and you can open your notebook, so we can pre-process this data meanwhile it's downloading. So guys, are we on same page? Can we proceed with the code? If you have any confusion or any question, you can ask. Otherwise, we'll proceed with the code.
I guess we can go ahead.
So we'll be reading this data, and we have a CSV file. So to read this CSV file, we'll be using different packages, like we'll be using pandas, we'll be using NumPy for data manipulation, and we'll be using some different packages if you want to split the data. Otherwise, pandas or NumPy is enough. If you don't have pandas or NumPy, what you can do is you can run this command, pip install pandas, and the second one is pip install NumPy. So if you are running these commands in your notebook, you can run like this with the magic command, with this command, or with this command. Okay. Otherwise, you can run directly in your terminal. Like here, you can run pip install pandas, because I have already installed these packages, so I don't need to reinstall these packages. So once we are done with the installation part, you can simply import pandas as PD, and then you can also import numpy as np, and then we might need this random package as well. Import random. So if you want to ignore the warnings, you can import warnings as well. Otherwise, no need to import this. So guys, let me know if you are done with this these imports. Okay, so we have imported some packages, then we have to read the data, and we can read data by using this pandas library. So panda is a library of Python which we can use to read different data sets in different formats like Excel, CSV, or tab separated. So you can use pd dot read underscore csv if you are going to read the csv file. Otherwise, if you are going to read the excel file, you can use pd dot read underscore excel. So because we are going to read the csv file, so we'll be using this pd dot read underscore csv, and you have to provide the path of your data, and you have to change these slashes. Okay, and then your data dot csv. Okay, so I have my data, so I can check the shape or head of my data. So here I am having the head of my data. So I have different columns like match event id and the location, coordinates, xy coordinate, remaining minute, shot, power shot, and knockout match. If it is knockout match or not, it's a binary column. And then the game session, and then the remaining seconds of the game, and then the distance of the shot, and then latitude, longitude, and then type of shot. So these are the different columns. Guys, let me know if you have done this, so we can proceed further. So if you are facing any issue while reading the data, please let me know. So if your data is in the same directory, you can simply provide the path of your data like this. Otherwise, you have to provide the complete path. So if my data is in same directory, what I can do is I can simply read data like this. Data is equals to pd dot read underscore csv, and then simply the name of the file with the extension csv. So I can read data like this. But if data is not in the same directory, so you have to provide the path, complete path of the data, correct? And then you can check the head, and you can also provide like number. If you want to check the first 10 rows, you can provide the number 10 or maybe 20, right? And you can also use tail to check the last 20 rows, or if you are not providing any value, so it will give you the last 5 rows, right? So let's check the shape of the data. So the shape of the data is this. So the first value is number of rows, and the second value is number of columns. So we have 30,697 rows, and we have 28 columns in the data, right? And then what we can do, we can use describe method. So what this describe method does, it will provide you, some basic summary or statistical summary of your data. So you will be having count, mean, standard deviation, minimum value, 25th percentile, 25th percentile, median, and 75th percentile, and the maximum value. So let me go to paint again, and let me tell you some few concepts. So if your data is normalized data, so you if the distribution of the data is normalized, then you will be having a bell curve. If you plot the data, you will be having a bell curve. So in this bell curve, this red line is representing the mean, and it is also representing the median. It is also representing median, because in a highly normalized data, mean and median are same. Okay, so mean and median are same. Okay, so when we can use mean and when we can use median, it depends. So for example, let's say if I'm saying that we have five people in the room, and out and let's say we are talking about the salaries of these five people. So out of these five people, the salary of four persons are like $20 a day for person one, and for person, let me open the Excel also. So these are very important concepts. So when you are dealing with the data analysis, so you have to have a very good concept of statistics, probability, and number crunching as well. So for example, we have five people in the room, and person the salary of the person one is $20 per day. Salary of the person two is like $22 per day. Salary of the person three is maybe $21 per day. Salary of the person four is $24 per day, and the salary of the person five is $200 per day. So we have outlier in the data, right? So if I calculate the average, so what will be the average? Average is mean. Average is nothing but mean, right? So if I'm taking average of all these values, just a second. Average. So we can calculate manually, guys.
No, I think Zaid, I think is not the good formula. You can use the FX search. I
No,
can.
I can just simply use this.
All right, divided by 5.
Yeah. Then we can divide it by 5. So the average is 57.4, right? So but so so this average is telling a totally different story, right? So this average is saying that we have $57 average salary for each person, but it is not the case. So the average salary is not 57.4 for every person. So we have a person who is outlier and who is getting 200 per day, and because of this outlier we are getting this average. So in such cases where we have outliers, we go with the median. So what will be the median? So in median, all we need to do is we need to sort these values, and after sorting these values, we can take the n plus 1 divided by 2. So that is 21. So first value will be 21, and second value will be 22. Third will be first value will be 20, then 21, 22, then 24, then 200. So the median will be this value, right? So in such cases where we have outliers, we are not going with the mean, so we always go with the median. So in this shape, where we have highly normalized data, the mean and median of the data is same, right? And then there is a concept of standard deviation, right? So what is standard deviation and variance? So standard deviation is how much your data is deviating from your mean or median value, right? So for example, in highly normalized data, within one standard deviation, so for example, let's say the mean of this data is 5, this is the mean, and mean is 5, and standard deviation is let's say standard deviation is 2, right? So one standard deviation right and one standard deviation left. So one standard deviation right means 5 plus 2, right? And one standard deviation left means 5 minus 2. So 5 minus 2 is nothing but 3, and 5 plus 2 is nothing but 7. So between 3 and 7, you'll be having 67% of your data, right? So you'll be having 67% of your data. So 67% of your data is one standard deviation away from your mean or median in a normalized data, and two standard deviation away, you'll be having around 70 to 80% of your data, and then three standard deviation away, you'll be having around 95 to 90% of your data, right? 99%. And then what is min? We have a formula for the min. If you are aware of this interquartile range, so please do search about interquartile range or 5 number summary, or 5 number summary. So in 5 number summary, we have five different things. We have max, we have min, we have 25th percentile. So 25th percentile is two standard deviation away. 75th percentile is also two standard deviation away. This is your median, and this is your min, and this is your max. So anything which is less than medium or anything which is greater than max will be considered as a outlier. So by using this describe method, we can get an idea about the simple statistics of the data. And then what we can do further, so we can check the data types of the columns, like data dot info. So here we can see the data type and non-null count. So non-null count means how many values are non-null. So what is the shape of the data? So shape of the data is 30,697 records. So out of those 30,697 records, we have 29,000 non-null values in this column, and same goes for all these columns. But in this column type of short, we have 15,000 non-null values. So this column is we have half values in this column. So we need to fill these values, we need to fill null values. But before filling the null values, we need to check the percentage of the missing values. So how we can check the percentage of missing values? So what we can do, we can create another data frame. So for example, if I do this, there is a method is null or is na. So this method will provide you the null values, or you can use is na. So I'm using this sum method. So I'm performing this aggregation on top of that, and I'm calculating the null value, the count of the null values. So this is the count of the null values in all these columns. But what we can do is we can create a data frame, and we can divide this with the shape of the data, and we can multiply it with the 100 each column. So shape of the data is the total rows. In shape of the data, we have the total rows. So total rows are 30,000. So we can divide the shape of the data with null values, with the summation of null values, and then we can multiply with 100. So what we can do is we can create a data frame like pd dot data frame, and in this data frame you can give the names of the column, like total maybe missing values, total missing values. And then you can provide, so this is nothing but a dictionary. You can create a dictionary with some key value pairs. So this is the key is nothing but the name of the column, and the value is data dot is null or is na, you can use, and then you have to do the summation as well. So this is one thing. And the second thing is we also need to calculate the percentage missing. So you can create another column percentage missing, and in percentage missing you can simply calculate the percentage missing by using this same formula, and then you have to divide this with the shape of the data. So shape of the data is data dot shape, but you cannot divide with the complete shape. So what you have to do is you have to divide with the number of rows. So this is shape. In shape you have a tuple. In this tuple you have two values, number of rows and number of column. So at 0 index you have number of rows, at index number 1 you have number of columns. So you have to divide with the number of rows, right? So we have to divide with the number of rows, and then we have to multiply it with the 100, right? So you'll be able to see the percentage missing in each column. So in these different columns, this is the percentage of missing value. So the highest percentage of missing values are in these column. Type of shot, 49% values are missing. Type of combined shot, and then game season, we have 19% missing values. Then is goal, we have 20% missing values. So something like that, right? So, guys, are you getting what I'm teaching you? So, how we calculated these percentage missing? So we simply calculated the null values, and then in second column we simply divided with the shape and multiplied with the 100. So this is how we are getting this percentage missing values. So you can also see the value counts. So value counts is another method in which you can check the count of the values of each category. So there are two type of columns in your data. So categorical columns and continuous columns. So what is the difference between categorical columns and continuous columns? So in categorical columns, you'll be having some limited number of categories. So for example, gender based column, or maybe a binary column having one or zero, or maybe with more than two categories. Like you can have a column for cities or for brand name. So maybe you have 10 brand names, so that column will be considered as a categorical column. So in continuous columns, or you can say a column where we have continuous number, not fixed categories, so those columns are considered as continuous columns. So it same goes for the machine ml modeling as well. So for example, if you are modeling uh, any column which is having categories, maybe two categories or maybe more than two categories, so then you are using classification models. But when you are having continuous values, like numbers, like salaries, or maybe remaining minutes, or maybe demand, you are forecasting the demand, so then you have to use regression. So I can use this value count method for any column. So we can use like a column where we have categories. We have this column is goal, so it's a binary column, so we can use this column to see the count of each category. So write the name of your data frame, then you can write the name of the column like this with dot, or you can write the name of the column like this is goal. So both are correct methods. And then you have to write the function name, and that function name is, method name is value counts. So it will give you the count of two categories. Like we have two categories, category 0 and category 1. Category 0 means no goal and category 1 means goal. And we have almost similar distribution, or we have class balance, like we have 10,000 record in this category and we have 30,000 records in this category. So this is how we can use some built-in functions. Then we can perform some exploratory data analysis. But before performing this exploratory data analysis, we can also drop some columns. So those columns are not necessary for our analysis. So what we can do is we can write data dot drop. So by writing this drop method, you have to provide the axis. So if you are writing axis is equal to 1, it means you are dealing with the columns. And if you are writing axis is equal to 0, it means you are dealing with the rows. And then there is another important parameter, that is in place. In place. So in place, by default it's false. So if you are writing true, it means that you are dropping a particular column permanently from your data frame, right? So if you are not dropping any column or any row permanently from your data frame, you should not write in place true. And if you are writing in place true, it means that you are dropping a column permanently from your data frame. So what you can do is in drop, you can provide list of columns, then axis if you are dealing with the columns 1, then in place if you want to drop those columns permanently. So in this list you can like provide the names of the column which you want to drop. So what we can do is we can columns, so I can get the column names like this list. So this is the list of columns. So I can drop like this column, and then I can drop maybe this column, remaining minute. So it depends. Here comes your domain knowledge. So while performing data analysis for any particular domain, like if you are working with a pharmaceutical industry, or you're working with a some manufacturing industry, or retail industry, or telecom, or banking sector, or insurance sector, so it is very important to have a very strong domain knowledge. So without having domain knowledge, you cannot take this decision either you have to drop a particular column or not, even in ML modeling or performing data analysis. So I am just dropping uh, randomly, so we can drop like uh, some more columns like power shot.
Zaid,
And
I, I think in this part we should reducing the data. That's, for example, use some techniques like PCA, like
sorry.
principal component analysis, to transform the data set to into a lower dimensional space. I think in this part after the
Yes, yes,
cleaning.
yes, yes, yes,
All right.
yes. So you can drop this one other than this one, remaining one, and power short one. So these are the duplicate columns, I believe. And then you can drop this knockout one, and then you can drop this remaining second one. So these are all duplicate columns, and you can also drop this. So okay, so if you are using in place true, then you don't need to save this in any variable, right? So you can directly run this, and these columns will not see these columns in our data frame. So see, we don't have these columns, so we drop those columns. So you don't need to save this into a variable like this if you are doing this in place is equal to true, right? So after dropping these columns, we can also change the data types, like data d types. You can write this d types to check the data types of your columns. So match event ID is float, and area of short is object. So some columns are object, some of them are float, and some of them are int64, right? So we can also change the data type of any column, like we can change the data type of date of game, right? So date of game is object data type, right? So we need to convert this into date data type. So how we can convert this? So we can write like the column name date of game like this, or you can also write like this: date of game is equal to. So you can use pandas built-in function, and that function name is to date time. So we can use this function to date time. So in this function we have to provide the column name which we want to convert, and that column name is uh, date of game. And we also need to provide, if there are some null values, we need to provide this queries, so we can avoid those null values. So let me check the date types. Yes. So we have converted date of game from object to date time, right? And in same fashion we can convert any other column to any other data type. Like we can convert this column game season to uh, game season to object, maybe from float. And you can use as type method. So in as type you can write object, or you can write float, or you can write int. So we can convert this column to object data, right? So this is how you can convert uh, your data types from one data type to another data type. And in game seasons, if you want to check like how many uh, unique, maybe how many unique game seasons we have, so you can check like this. So let me store this uh, in a variable like unique. And then you can also uh, calculate the length of these unique seasons, and then we'll convert this into a numpy array. So we can convert, check the length. So length function is nothing but it's a built-in function, and you can use this function to check the length of any list or any array. So length of this, just a second, L unique is not defined. Okay, my bad, sorry. So the length is 21. So I can convert this into a into a range by using numpy, and then I can store this into another variable. So what we can do is we can convert this into numpy array. So after converting this into a numpy array, we can store this into like another variable, and then we can use both. Just a second, numpy array. Sorry. Okay. So we can convert this into we check the length of the unique game seasons, and then we convert it into a numpy array by using np range function, and then we stored this into another variable. So then now we can use both of these variables to calculate the game seasons, like if it is game season or not, like something like that. Just let me data game season. So we can in game season actually, let me show you. So we have nan values, right? So we have to uh, you know replace in categorical data. So this is categorical data, right? So replacing categorical data with numerical data. So we have to replace these categorical numbers with numerical numbers. So that's why we are performing this operation. So what we can do is we can simply use replace method, and in replace method we need to provide what we have to replace. So let me show you. Okay. So we have to replace these values into numerical numbers. So we have to provide like to replace. There is a variable to replace. So to replace will provide unique values, and then with the value we want to replace. So we'll provide this v unique, and then in place true. Okay, so data game season. Mm, okay, so we have replaced the categorical values with numerical values. So these numbers are not making any sense, right? So we just converted those numbers into numerical numbers like season 1, season 2, season 3, so something like that. So then we can also change the data type. So the data type of game season was object, and now we can change the data type. So to change the data type, what we can do is we can uh, simply write as type, and in as type we can write int. So it will convert the data type to integer. So from object, it converted the data type to integer. Now we'll learn how we can handle missing values. Just a second. Okay. So how we can fill missing values? For example, let's say we have uh, we have a property business, and we have some listed properties in different cities, and city 1, city 2, and city 3, right? And we have uh, for each property we also listed the price of each property, and now we have some missing values, some missing prices of some properties. How we can fill those missing values? So let's say the scenario here is, so we have three cities like city 1 and city 2 and city 3. So we have three cities, and in each city we have different like properties. We listed different properties like property 1 and property 2 in city 1, right? Or maybe property 3. So these are for the city 1, and there are some other properties for city 2 as well, and some other properties for city 3. But we have, let's say, for this property we won't have the price, right? So missing value. So there is another property like prop. So there are multiple properties in this city as well, and there is a property like property 6. So for this property we have a missing value, and same goes for this. So we have three properties: property 1, property 2, and property 3. And for this property we have missing value. So how we can fill these missing values? So there is one way to approach this problem is that we can we can simply, take average, overall average. For example, uh, the price of property 1 is, let's say, 50, and the price of property 2 is, let's say, 40, and the price of this property, let's say, 90, right? And the price of this property, let's say, 60, and then the price of this property, let's say, maybe, I don't know, maybe 30. Okay, and its properties 20. So the one way is I can sum 50, 40, 90, 60, 30, 20. I can take the average, and I can impute the missing values with the average, right? But this is not the right approach. Why? Because in each city we have different prices. See, the price range in city 1 is between 50 to 40. The price range in city 2 between 90 to 60. The price range in city 3 between 30 to 20. So I cannot use a holistic average or a single average value to fill all these missing values, right? So there is another approach, there is a way around. And that way around is, so we have to lock this city. We have to take average. The average will be 45. So to fill this missing value, we can use 45. And then we'll lock this city, right? We'll lock this city. So to lock a particular city in Python, what we can do, there are different techniques in Python and in SQL. So in SQL we use partition by, right? Partition by. And in Python we use group by or log or ilog. So these are important method, guys. You can note it down. So log or ilog. So we use log just for the when we are using column names, categorical column names. We use ilog when we are using index. We use group by in Python, and we use partition by in SQL. So how we can use this, I'll show you in a bit. So the second approach is we log each city one by one, and then we take average, and then we can impute the values by taking average, right? So for this city it will be 90, 60, and 150, 75. So it will be 75, and then for this city it will be 25, right? So this is how we can impute the missing values in numerical column. But what if we have a categorical column? Like there is another scenario. So this scenario is clear, guys, right? Let me show you another scenario. So let's say we have a categorical column, and in that column we have maybe we are having maybe product name or brand name or gender, something like that. Product name, like I have a column of product name, like product. So I have a column of product name. So in this product name, I have some missing values. Like, for example, this is product one, then product two. Then I don't have values for like one, two. Then I don't have values for three and four, and then I have value for five. Then I don't have value for six. Then I have value for seven. So, or maybe I have value for 6. So I have to fill this 3 and 4. So how can I fill these values? There is one approach that you can take mod. So mod is nothing but the most frequent value, right? But can we directly fill all these categorical column, missing values of this categorical column by using mod? Can we do this? No, this is not a good approach. The second way around is you can combine this column with another column. Like product name, for example, we have another column and that is brand, right? So what we'll be doing here is we'll be locking the products with their respective brands. So for example, these so some of the products, like maybe we have brand A and this is brand B. So brand B, and third one is brand B, fourth one is brand A, and then so on and so forth, like A, B, so something like that. So what we'll be doing is, so to fill the value for this three, we'll be taking the mod. So the brand of this product is B, right? So this product is from brand B. So we'll be taking the mod of all those products from brand B. So the most frequent product in brand B, we can fill the missing value, or we can impute the missing value by using that value. So is it clear, guys? Okay, let's proceed with the coding. So in Python we have a method, fill any method. So we use that method to fill the missing values. So in fill any method, we can provide a parameter like ffill, bfill. So ffill means forward fill, bfill means backfill. So in ffill, for example, in this case, if I use ffill, so it will what it does is it will fill these missing values by using this value. It will fill this, and by using this value, it will fill this value. So this is how forward fill works. So if I use b fill, backfill, so it will use this value to fill this value, and then it will use this value to fill this value. So this is how the backfill works, and this is a very simple approach. But we'll be using, for example, we have missing values in power of short. So what we can do is, so we have a column, uh, power of short. So in this column, what we can do, we can uh, fill na. We can use fill na method to fill the missing values. There is a parameter called value. So in value, what we can do, we can use the same column. and we can take the mean. We can take the mean, and it will fill all the missing values by using the mean. Just a second. So it was marked down, that's why. So now we don't have any missing value. If we check data dot is na dot sum, so you'll not have any missing value in this power of short, right? So this is how you can fill the missing values in all different columns. And then you can also use mod. So I'll show you another example of mod. Then we'll jump to the Power BI part, because this data pre-processing will take too much time, and I don't want to waste uh, your your time. So we'll jump to the Power BI. So you can I'll share the complete notebook with you guys. You can practice on your own. So in mod part, what you can do, you can calculate the mod. So how you can calculate the mod? So you can, for example, there is a column. Let's take one column. Let's take this column, right? So in this column, we can use value counts, and in value counts we can take keys, and in keys, from keys we can take zero. So what actually I'm trying to do here is, just let me show short 3, right? So so when we perform value counts over a column, so it will give us the count of each category, right? The count of each category. So the most frequent category is short 3. So this short 3 is a key of the result, and then from key we can use indexing. So I have used 0, so it provided me the key. So this short key is the mod of this column. This short key is the most frequent value of this column. So this is the mod. So by using this mod, what I can do is, I can simply mm, use this column. So write like this column, fill na value is equals to this, and then uh, you know in place. So we have in place. Okay, so now we filled the values of this data frame, sorry, this column with the mod, and the mod was this is one way to check the mod. There are many other ways, like you can also check the mod by describing the data, or by directly using the mod method, right? And then you can also fill values with the median. So with the median, like for example, there is a column which is let me check the columns. So there is a column remaining second. So we do have null values in remaining seconds. So remaining seconds. So in remaining seconds, we can use fill NA. In fill NA, we can provide the value, and that value will be the median of this column. And you can use the data frame name, then the column name, and with the column name you can directly use median. So by so let me show you what is the median of this column. So the median is 28, right? And then simply in place true. Okay, in place true, in place true. Sorry. So in place true. So this is how you can fill the missing values with the median, right, guys? So we can proceed with the Power BI, right?
Yes.
Okay. Let me open an already created dashboard. So then I'll explain every bit of this dashboard. Guys, you have downloaded the Power BI?
Yes, yes. I have it. I use it in my work.
Okay. Okay. So this is a sample dashboard which I have already created for a client. So in Power BI, there are some important things. Let me show you that. So just a second. So this is the empty canvas of the Power BI. So what you have is you can use this get data, and from this get data, if you will open the Power BI, you will see the same page, right? So there are different components of this Power BI. So from this get data, what you can do is you can read the Excel workbook directly, or you can read the Power BI data sets, or you can connect with the data flows, SQL Server. Like for example, if you are having data in SQL, so like I am having data in SQL Server, right? So this is my database name FOSROC. So in this database, I have like table which is called dashboard. So in this table, I have a flat file maybe, or I have a single table. In this single table, I have some information which is related to this Fosrock company, right? So I can connect with I can directly connect with the SQL server as well, or I can import a flat file as well. So there is a button of more. So if you click more, you'll see more options, like you can connect with your Parquet file. So what is the difference between CSV file and Parquet file? It is Parquet is a different file format. So to create a lightweight data set, you can convert your CSV file into a Parquet file, right? And you can also connect with IBM Netezza or MySQL DB. So you have all the options. You can connect with Impala, you can connect with Vertica, Snowflake, right? You can also connect with KQL. So KQL is nothing but Kafka Query Language Database. You can connect with the Lakehouse. Sorry.
Different data sources.
Yes, you can connect with your blob storage. So what is your blob storage? Your blob storage is nothing but uh, it's a simple file storage where you can store, where you can create a container, and within that container you can create folders, and within those folders you can put your data, right? And you can connect with the SharePoint. So you have all the options, you have all the options, name it and you will have it, right? So you can connect with the data source. After connecting with the data source, let me upload a sample data. Just a second. I think just
Please, Zaid, what is the difference between Parquet and CSV?
okay. So Parquet is a different. There is a technique, compression technique, which we use to convert a file from CSV. Maybe it could be any format file, like CSV file or any file. So you can convert that file into a Parquet file. So Parquet is a lightweight format. So it is lossless compression. Lossless compression means if you're compressing your data, for example, I have five values in my data, right? And I am compressing my data by using any compression technique. There are two types of compression techniques. So some compression techniques are very faster, but they are lossy, and some compression techniques are not very faster, but they are not lossy as well. So you can compress your data, but at the same time you are not losing your data. You can keep all the data, but your file size will be, very smaller. And in Parquet you'll have, three or four or maybe five different blocks of the same file. So like for example, if I'm having one single CSV file, so if I'm converting into a Parquet format, it could be a one single file, or it could be three to four different blocks of the same file.
All right, and always the extensions of the file is .csv,
Sorry.
and always if we use the Parquet technique, the extension of the new file will be .csv.
No, we are not using. This is not, I mean, must to do. I mean, it depends. For example, if your file is like in GBs or maybe in TBs, right? So CSV file can go up to GBs or TBs for big data sets.
All right.
So if you will load, because we have limit within Power BI, so we can read 1 million rows in Excel. So if you have more than 1 million rows, you cannot read in Excel. In Power BI you can read up to 3 to 4 million rows easily, right? And if you are writing dex query on top of that, you will be easily able to, transform the data, or you can create different charts. And if you are changing the filter, it will not take much time to change the charts, right? If you are having less than 4 million rows. But if you are having more than 4 million, like 10 million rows or 20 million rows, so CSV format is not recommended. So you can convert the file into a Parquet format.
All right, thank you.
No problem. So we can load the data, and like for example, let me load this formulation to data. So if you have multiple sheets in your data, you can select the sheet. So I think only having one record here. I don't know. Let me check. Okay. So here you have your sheet, right? So these are all column names, right? And what you can do is you can go to the transform data, and in this tab you have data source settings, and you have transform data option. So in data source setting, for example, so initially when you started your analysis, your data was in blob storage, or maybe in your local storage. Then you migrated your data from your blob storage. Your data is saved, but you migrated your data from your blob storage to maybe MongoDB, right? Then you have to change some settings from this option of data source setting. So all you have to do is you have to just provide the credentials and the path of your data, of your MongoDB. Then you will not you will not have to perform any kind of tweaks on top of your dashboard. And then you have the option of transform data. So if you click over here, you'll see this power query here. So because I'm having only one row in this data, so just I'm trying to explain some things. You can change data source settings from this page. You can add new columns, you can remove some rows, you can remove some columns, and whatever steps you will be performing here, that those steps will appear here. For example, if I want to remove a column, right? So I have removed a column, and you can see these are all applied steps. So if I'll click here, so it will undo the last change, right? So for example, I remove this column and then I also remove this column. So here in these applied changes, if you will change, if you will cross this from here, so it will undo all the changes. You can keep some rows, you can remove some rows, or you can also, I mean, change the data type of your columns. For example, this clinker is, so this is the data type. So right now clinker value is in whole number. So you can simply change the data type from here. It is just like Excel. So you can change the data type, and you can also run some merge queries. So in merge queries, you can combine two columns, or you can also replace the values, or you can perform group by, you can split the column. So for example, let's say in this factory name I have two values. One value is in the bracket and the second value is this pvmgcin, right? So I want to split these two values. So what I can do, I can use this option of split columns, right? And then you have to go here on the upper left corner. There is an option of close and apply. So whatever transformation you are performing here, at the end of this you have to click here on close and apply. So after clicking here close and apply, it will perform all the changes on your data, right? And the second important thing is, you have three main components of Power BI. This is the first component, this is the second component, and this is the third component. In first component, you can create chart and you can add as many pages as you want to create some charts. And in second component, you can view your data. So this is the data. And in the third component, this is very important component. Here you can create a data model. So for example, let's say I am having two or three or four different columns. Like, let me go back to this dashboard. So if I'll go to this model, so I'm having three different table. So sheet one, so I can rename these sheets. So sheet 2, sheet 3, and this retail price is sheet 1. So this is what I was talking about. So these two sheets should be working as, right now these sheets are not working as proper dimensions, but these two sheets should be working as dimensions, or at least there should be some dimensions with the fact tables. So let's say I'm having two fact tables, but I have to have, you know maybe one, two, three, four, or more than four dimensions as well. So what we can do is we can connect the similar columns, like product ID. This is the relationship between product ID and product ID, and you can see steric here. So this steric is saying that we have many to many relationship. So this is not the good relationship in Power BI. While modeling your data or creating a data model, you cannot have this many to many relationship. You should have one to many relationship. So when I say one to many relationship, let me explain this concept very clearly. So these concepts are very clear. So if you are going for the interview for the Power BI developer, you should know what is data modeling. I mean, there are some important questions, like you should know what is the difference between OLTP and OLAP. So OLTP is nothing but your transactional database, and OLAP is nothing but your analytical database. You should know what is the difference between a data warehouse and data mart. And you should also know what is the difference between dimensions and fact tables. And you should also know what is the difference between all those three different type of schemas: star schema, snowflake schema, and galaxy schema. And you cannot have many to many relationship in your data model. So that is a very very bad practice. Right now I am doing this. This is This is just just a one time solution. That's why I created this uh, this many to many relationship in this data model. But this is very bad practice. So what you have to do is you have to create dimensions. So for example, let's say I have only one dimension, and this dimension is like city. Okay, this dimension is city. Okay, so this is my one dimension. So I have city 1, I have city 2, and I have city 3. So these are the only cities in my dimension. Then I'm having a fact table, and this fact table is sales table. This fact table is sales table. So listen to me very carefully, guys. This fact table is sales table. So in this sales table, I am having multiple transactions for each city. So for example, uh, let's say I have another dimension date, right? So this is day, not date, right? Just for the sake of example. So city, like city 1 1, city 2 2, city 3 3. So these are the IDs of city. In day I am having only 1, 2, and 3. So these are the days. So I am having some rows. So this will help you to understand the concept of the dimensions and fact table. And I hope you will never forget, because I am explaining this concept in a very simple manner. So this column is day column, this column is city column, okay, and this column is quantity column, quantity sold, right? So for day 1, in city 1 1, in city 1 1, I have sold 200 units, okay. And for day 1, in city 3 3, I have sold 50 units. For day 1, in city 2 2, I have sold 70 units. For day 2, in city 1 1, I have sold 50 units. For day 2, in 2 2, I've sold 90 units. And in day 3, we don't have sale for this city. For this city, we have sale for only this city. Uh, like 60 units. Or maybe another. Let me add another city. One more. Okay. Now see, guys, this dimension, when I'll connect this city with this column, so it will have one to many relation, right? Because cities are not repeating in dimension. In dimension, you have unique cities without any duplication, without any repetition, right? But in your fact table, this is your fact table. In your fact table, you have the repetition and the duplication of the cities. So city 1 1 is here as well, city 1 1 is here as well, and city 1 1 is here as well. So that's why this relationship will be something like this: one to many. This steric means many times, and if there is no steric, it means one time, right? And same goes for day. So this day 1 is many times here, like one time, two time, three time. So same goes for day 2, same goes for day 3. So this day dimension, when I'll connect with this day, it will have same relationship, one to many relationship. So while doing the data modeling, what is data denormalization means? This is what we mean by data denormalization. We'll find the unique dimensions. So these are slowly changing dimensions until unless I am not selling in any other city, these cities will be fixed, right? So these cities are not changing very frequently, right? That's why we call them slowly changing dimensions. So in dimensions we don't have any duplication, we don't have the repetitions, but in fact table we do have the duplication, we do have the repetitions. Am I correct? So that's why we have one to many relationship. So we call this type of schema star schema. So this is star schema where we have two dimensions and one fact table, or maybe three dimensions one fact table, or maybe four dimensions one fact table. So if we have one fact table with multiple dimensions, that type of schema is called star schema, right guys? So that's why if anyone asks you that can we have many to many relationship, steric to steric, no, we cannot have steric to steric. I mean, it will work in some cases, but this is very bad practice, right? So it will hurt your analysis sometime. So these are the three different components: charts, and here you can see the data. Like you can see any table, like this is the retail price table, this is the another table where we have the information related to product, transfer from, transfer to store, allocated stock, and then we have some inventory and forecasting table. So because we are running out of time, so I can hand over this dashboard to you guys as well. So this is a very simple dashboard. What you have to do is, if you want to create a chart like card, so you can simply click here, right? And so this is card, guys. You can simply click here, and for example I want to take this mission of 28-day strength. I can click on the value, and then you can also format it. So to format it, so you can go to the this button, and in this button you will have two options: visual and general. So you can turn off the category label, or you can go to the journal. You can turn on the title. You can write your own title, like total.
Zaid,
Yes,
sorry for interrupting you. If we can export the data set about Ronaldo and use it here in the Power BI, because this one have just one row.
yes. I mean, we can do this, but we need to perform some more pre-processing on that data.
All right,
So
all
it
right.
will, yeah, it will take some time. That's why. So I mean, the basic idea is same. The basic concept is same. I'll create a dashboard of the Ronaldo's data set, just like this dashboard, and I'll share that dashboard by tonight, by end of the day today, with you as
Okay,
well.
thank you,
Okay.
thank you.
So
Because
yeah.
we created a folder in Google Drive, and then we can share all of this in the same
Yes. Yes.
folder.
Sure.
Yeah,
Sure.
thank
Sure.
you, thank you.
Sure. Sure. No problem. So this way you can, I mean, uh, create a heading, and then you can bring it to the center, right? And you can resize it. So in similar fashion, you can create multiple cards. Like let's say I'm having three cards. So and you can also create a filter. So there is another chart like this one. This is a slicer. uh, this is a slicer, just multi-row slicer. We do have filters, guys. Mm, hmm, just a second. I think we have this filter, yes. So we can use this filter and we can filter it on base product name, probably yes. So this slicer, you can use this slicer to create a filter. You can go here, uh, you can filter the data on, because I have only one row, that's why I'm just seeing this. Let me go back to this. So just a second. So you can select this filter and you can select any categorical column, like for example, mm, mm, so you cannot create filter by using continuous values. So you have to create filter by using any categorical, like the product id, right? So I have three product ids, right? So I can create a filter by using three product ids. So then we can create another filter by using store id maybe, right? So we have different stores, so we can create another filter from store id. So you can also format it from here, right? And in similar fashion, you what you can do is, just let me go to measurement. In similar fashion, what you can do is you can go to this three dots, and you can get some more visuals. You can download some visuals. So people have created by using JS or JavaScript. People have created so many visuals. So you can get some visuals from this store as well. The way I'm using this Sankey chart. So this is what we call Sankey chart. If you Sankey chart. So Sankey chart. So these are the Sankey charts, right? So these are not these type of visuals are not available by default in the Power BI, right? So what you can do is you can simply go to this uh, import visual from file or get more visuals, and you can import this filter. So this Sankey chart is nothing but it representing the relationship between two stores, like from store number 7 to store number 10. It is saying from store number 7 to store number 10, transfer we can transfer 5 records, right? And from store number 15 to store number 11, we can transfer 6 units. From store number 6 to store number 3, we can transfer 2 units. And these are nothing but these are the simple your bar charts. You can create these bar charts or clustered bar charts from from any of these charts. So these are some bar charts like in vertical and in horizontal direction. You can convert as per the requirement of your canvas or as per the requirement of the KPIs you wanted to create. So this is how you can create a very simple and very basic dashboard. So what I'll be doing, I'll be creating a similar kind of dashboard with few cards, with few filters, and with some bar charts, and maybe a Sankey chart as well, with some line charts. And I'll share that with the team, so the team can share the data set and the Power BI dashboard along with the Jupyter notebook with you guys, so you guys can practice. And I'll also be sharing a two long videos of a workshop. uh, I'll zip those videos and I'll send to the team. So in that workshop, that is 8 hours workshop. So in that workshop you will be able to, if you follow that workshop, you will be able to crack the Microsoft certification of Power BI. So I'll be sharing that workshop with you guys as well. So if you have any question, you can ask.
Thank you, Zaid, for this session. I think all is clear, and after that session, we're gonna share the Google Drive with the participants.
Sure, sure.
As you know, we
I'll,
have a community in WhatsApp, and people can join and maybe.
so let
Uh,
me share in the chat what I'll be sharing. I'll be sharing notebook,
all right,
and I'll be sharing the
give me,
data set.
give me your email. I will give you the access of the drive in the
That's
chat. Yeah,
sure.
in the chat. Give me your email again.
And Power BI workshop videos. So these are the four things which I'll be sharing with you: notebook, dataset, Power BI dashboard, Power BI workshop videos. So here is my email.
All right, you have the access now, Zaid, to upload all of this. And
Sorry, the
thank
access of what?
you have the access
Um,
as a editor in the Google Drive in the folder. You can check it in your Gmail.
Okay.
I or just by clicking in the link I shared in the chat. Okay.
Sure, sure. I'll check. Thank you.
All right.
So
Yes,
thank you.
Kauchar, you're gonna say something?
Asma, do you have any question?
I think Kauchar wants to say something.
no, I just want to explain to him that you give him access to the Google Drive. That's it. Thank you,
Yeah, I
Zed,
did.
again for the
Thank you.
this
Thank you, guys. Thank you. It was very nice,
Yes,
meeting you again.
see
So
you
we'll
tomorrow.
see you. Yeah.
tomorrow.
Yeah.
Tomorrow, inshallah.
Good night, Zaid. Thank you.
Good night. Take care. Allah Hafiz.
Thank you so much.